Good evening, everyone. This is Jeff Ashby. I'm one of the field leaders for Engage Global, and I am so honored this evening to have been asked to host tonight's call, the science call with Dr. Kedar Prasad. Very excited about the information that we're going to be going over this evening. To keep us both on track, I know that many of you have submitted questions, and Dr. Prasad is here this evening as the answer man, but we're going to be focusing on more of a narrow topic this evening. But it's a narrow topic, but when you see the full presentation, you'll understand just the incredible opportunity that we have to have Dr. Prasad here with us this evening. So, Dr. Prasad, go ahead and say hi to everybody, and then we'll start the presentation.
Yes, hi Jeff, and hi everyone. I'm glad to be here and to discuss today's topic. Jeff has how radiation causes damage and what we can do to protect ourselves against radiation damage, both ionizing as well as non-ionizing radiation. So this is my great pleasure to be here this evening to discuss with you, Jeff, and your colleagues.
Fantastic, Dr. Prasad. So I'm going to go ahead and just start sharing my screen, and we'll jump right into the presentation here. So here we are, the science and the scientist behind the products. Fortunate enough to be here with Dr. Kedar Prasad this evening. I love this statement here. Every dose is effective, every ingredient is active, every nutrient is absorbed, all of it. You're going to see tonight as we unfold this presentation just how critical this actually is. So here's a picture of Dr. Prasad. And I'm going to give you just a little bit of brief bio here. It's up on the screen for those of you that want to follow along. But Kedar Prasad earned a PhD in radiation biology from the University of Iowa and joined Brookhaven National Laboratory for postdoctoral training. He then joined the University of Colorado Medical School, where he became the professor and the director of vitamins and cancer research. In 1982, he was the first to show that vitamin E succinate can be used to kill mutated cells. He also scientifically demonstrated that multiple antioxidants are more effective in killing dangerous cells than individual antioxidants. Instead of going on and talking more about all of the books, we're actually going to share some of these books here with you this evening. The other thing I wanted to point out is Dr. Kedar Prasad is the first radiation biologist, PhD, in the entire world, and that's tonight's topic as we talk about radiation and microdaily. Here we're looking at the electromagnetic spectrum. Those of you that can see the screen, you can see the non-ionizing and the ionizing. And Dr. Prasad, if you want to just go ahead and describe a little bit of this, why understanding the electromagnetic spectrum is important for individuals. Go ahead.
Yeah, I mean, recent studies suggest that it has been known for a long, long time, and it is fairly well established that ionizing radiation, which called damage, increase the risk of many human diseases, especially cancer. And an example of ionizing radiation would be X-ray, gamma ray, proton radiations. And non-ionizing, and the difference between ionizing and non-ionizing radiation is that ionizing radiation knocks out one electron from the molecule and then becomes very reactive molecule, free radicals. But non-ionizing radiation doesn't have capacity to knock out any electron. And so it has just the waves, and they don't produce they also produce a certain amount of free radicals. But the recent data it has been shown that non-ionizing radiation, if you are exposed for a prolonged period of time, for example, UV light, if you are exposed to prolonged period of UV light, you may develop the risk of melanoma. And if you have a microwave or any kind of electromagnetic radiations, if you are exposed for a long time, there is a risk of some kind of cancer has been proposed. And these are all epidemiologically studied. Nobody has in human as yet where they actually expose the non-ionizing radiation at a given frequency and study their effect. But many animal studies and cell culture studies shows that prolonged exposure to non-ionizing radiation, whether it's ultraviolet or whether it is electromagnetic radiation that we have in our cell phone or microwave or many other television. And so the issue is that how to protect ourselves first from the ionizing radiation and also from the non-ionizing radiations. You know, we are getting exposed to ionizing radiation when we go for X-ray, for your CT scan, background radiation. So we can't get away from radiation. It is a powerful tool.
Exactly, and thank you, Dr. Prasad, for making this transition here with the slides. What I have up on the screen here is the effects of ionizing radiation, and you did such a good job pointing out the difference between the two, non-ionizing radiation and then ionizing radiation. If you look down here over on the left-hand side of the screen, it talks about tolerable levels, moderate risk, and high risk for these radiation effects. The most important thing here on the screen is something you've already pointed out, and that is that radiation is cumulative, whether it be ionizing or non-ionizing radiation, like you've already pointed out there with the ultraviolet light. So as we go on with the presentation, I'm going to really kind of start back in the beginning. This, Dr. Prasad, is as you've described to me, the first book that you've published, and what is it about here? I mean, human radiation biology, back in 1974.
In this book, I have mostly emphasized what are the potential effect of high doses of ionizing radiation and low doses of ionizing radiation on human, and so it more focuses the damage to the human various organs. For example, in human, our bone marrow, for example, testes, any reproductive organs, blood cells, they are most sensitive to radiations than, say, for example, brain tissue, or, you know, as far as the cancer is concerned, when you say which cell type is most sensitive to radiation, you have to define on what criteria. If you are talking about the criteria of cell death, for example, intestine is extremely radiosensitive, and then, but this is a high dose of radiations. Low doses of radiation, then most of the time we are most concerned about is the development of cancer risk, and also some genetic mutations that can be inherited from parent to children and so on, familial type of mutation. And so, but most of the time we are concerned about the low dose of radiation rather than high dose of radiation, except for radiation therapy. Then there you have to have a higher dose of radiation. And so this is very important to remember. And also to remember that ionizing radiation like X-ray or gamma rays cause damage to your cell by producing extensive amounts of free radicals that also leads to extensive inflammation. So these two are, again, common factor, even radiation injury. High radiation dose produce more, low radiation dose will produce less. Nevertheless, it is important to know these are the two main things by which they cause damage, namely free radicals and inflammation.
That is fantastic, Dr. Prasad. And back in 1974, this first book of yours is talking exactly about that. I'm going to go ahead and share with another several of your books. So just a moment, we'll start the screen share here, and we can get right back to the other books that you had here. Okay, so Handbook of Radiobiology, and I just pulled this off of Goodreads, but it says this book contains up-to-the-date data on the latest effects of low-level radiation on humans. And you understand, look, it was published back there first in 1984. So 10 years later, Dr. Prasad is still writing here about radiobiology and its effects on humans, and this is the second edition, meaning there was enough people out there interested that there was another edition in 1995. Is there anything that you want to say about this particular book, Dr. Prasad?
No, this book was a textbook, was recommended for for many universities and laboratories where they had a radiation biology book. And so this was a kind of reference book. Here I also emphasize quite a bit of radiation protection by various agents, both pharmaceutical agent as well as the micronutrient. And so this book also deals with some of the recent study that has been done on a human, for example, in Chernobyl accident when they were exposed to low level of radiations in the surroundings. And so this book emphasizes radiation protection plus basic how the radiation causes damage, late effect, as well as acute effect is very important to remember that.
Well, it's just amazing that we have you here, Dr. Prasad. There is no one who understands more about radiation and its effects on the human body than you. And truly, it's why the Department of Defense reached out to you. I mean, they actually sought you out and asked if you could help them protect our soldiers. I've got up here on the screen one of the cooperative research and development agreements that we're going to be dealing with this evening is the very first one. It's the Space Act Agreement, the development of a successful protection formula against radiation-induced oxidative injury in vulnerable populations. And so, as I understand it, and you can share a little bit more about this. In fact, let me just take the screen share off so that we can see you. Right, here we go. You want to tell us a little bit about this, the background on what's
Yeah, I mean, as you know, that NASA has been always very interested in radiation protection because when astronauts are on lunar surface, they are likely to be exposed to radiation. So radiation protection has been one of their major interests, how to protect astronauts from radiation damage. And so when a colleague of mine was there and who contacted me, if we can do something that can be also a protective strategy for astronaut. And so first, of course, we have to do in the animal study to demonstrate the principle that micronutrient can protect against radiation damage. And so that was the cooperative agreement. And the reason we put there, because at that moment we thought that the radiation protection issue is not only for the astronaut, but also surrounding people who are of the laboratories who are exposed to little higher level of radiation than, say, if you are staying away from that installation, that's NASA installation, because there's a lot of radiation-related equipment. And so, but the main objective was, for NASA, as far as the NASA was concerned, can we protect astronauts from radiation injury when they are exposed to on lunar surface?
That's awesome. I'm going to go ahead and pull the screen back up here so that we can look at some of those studies that you were referencing. These are animal studies that were supporting the development of this antioxidant formulation. In fact, maybe you can, for the benefit of our viewers out there this evening, talk a little bit about some of these, beginning first of all, and you corrected me, the murine radiation model. I didn't understand that was on mice. You want to share a little bit of that study?
That is a scientific name, murine. But here we study the formula that we had was the antioxidant, multiple antioxidant that we have in the microdaily. The same antioxidant that they are there, but it was only antioxidant, not vitamin B12 and other just pure mixture of antioxidant. So in murine model, in mice model, we gave them a prior to radiation orally, and then gave a dose of radiation which will kill 100% of the mice within 30 days. But if you give them, this is control mice. If you don't do anything, all mice, 100%, will die within 30 days. And this was a high dose. And we call it bone marrow syndrome because they die because of the failure of bone marrow. But when they were treated before radiation with this multiple antioxidant, then 40% of lived for a long time, indefinitely. Mice live generally 3 years, but we did not follow their study 3 years. We follow, if those guys who live 30 days, then they are going to live their normal life. So in this scenario, the control which did not receive a multiple antioxidant formulation that I developed for them, all died within 30 days. But those who received this formula, they died, they only 40% of them live for normal life, live almost normal life. So they survived 30 days and they live their normal life. And so this was a demonstration of that micronutrient has a powerful antioxidant. And if they can protect high dose of radiation, I'm sure that the same micronutrient can protect against low dose of radiation, such as you see in a X-ray or dental X-ray or CT scan.
We're going to get into some of those later in the presentation, Dr. Prasad. Let's look at some of those other animal models, starting next with the sheep, and then the rabbit, and then the fruit fly. In fact, maybe you want to work them that way. Start fruit. Well, you know what? I actually have a slide for the fruit fly. So let's talk about the sheep one first with the Russian.
Sheep study. It is very difficult to get a permission in this country to study a large animal. Impossible. And so NASA has a collaboration with Russian Federation, Russian Academy of Science. And so the sheep study was performed in Russia. And we have the same formulation that we gave to the mice. It was in a powder form. And they gave a very, very high dose, much higher dose than mice got it. And in that scenario, the control, the sheep that did not receive any formulation of multiple antioxidant died in 7 days. Within 7 days, 100% died. But those who received, and without any other one, without any other treatment, those who received our formula lived 37 days. And my feeling was that if they would have gotten other supportive care, for example, in this country, if somebody gets a very high dose of radiations, like bone marrow transplant, they get a lot of supportive care, electrolyte imbalance, electrolyte infusion, blood transfusion, bone marrow transfusion, all these kind of things we would have given. Probably those sheep would have survived. But anyway, even with micronutrient alone, their survival time was increased from 7 days to 37 or 38 days. Some 37, some died 38 days. So this is again with such an extremely high dose, and we call it a GI syndrome dose, gastrointestinal syndrome dose. In case of human will die within 2 weeks, 100%. But the sheep was more sensitive, so he died in 7 days. But the fact that we can improve their survival time by 4 or 5 times is amazing. It's an even high dose of radiation.
Wow, that is amazing.
That was very exciting in terms of a potential of multiple micronutrients providing such a powerful radiation protection.
Let's go on. I want you to, you sent me over a screenshot of your computer about the fruit fly ones, and so let's go look here at the fruit fly study.
Yeah. Here is the fruit fly study, and this study was done with Moffitt, California here, and Moffitt Field, California, with NASA. NASA has a huge institute there where they did this kind of a study. And they were interested in a proton radiation, and proton radiation is 10 times more damaging than X-ray or gamma ray. And the reason they selected to study proton radiation, because when astronaut is on lunar surface and when there is a solar flare-up, they emit a lot of proton type of radiation, not X-ray or gamma, but proton radiation. So this is what their main interest. That's why we use proton radiation. You can see that the red one is the one that is this is fruit fly mice, and in fruit fly mice, the scientist there, Dr. Bhattacharya, inserted a leukemia cancer causing gene, because normally fruit fly don't develop cancer, but when you insert them, they start developing cancer. And when they gave radiation, you can see in the second slide that almost 3.5 times more tumor they develop than the control. And you can see that control is a blue one. And when they were fed, same formula, multiple antioxidant before 7 days before radiation and continue to feed 7 days after radiation, you can see the next slide which say plus micronutrient there. They bring to a almost like a control level, which does not receive any radiation. And so this is another very, very good example of not only that it can protect against even a proton radiation, against radiation damage, at least on the criteria of cancer. And it also demonstrates the first demonstration in any other organism that a genetic basis of the disease can be prevented by micronutrient. So this demonstrates two principles, but it is a powerful radioprotective agent. And second, that even in case of genetic disease, at least in fruit fly, it can prevent the occurrence or manifestation of the genetic disease.
Wow, Dr. Prasad. I mean, what we're looking at here on this screen shows that it was like none of the fruit flies developed the tumors.
Right.
And it's like, how often does that happen in a study where it's all one way or all the other, and the only difference was the multiple antioxidant micronutrient formula that
Amazing. Amazing.
It's also interesting for me to know that that the micronutrients are so small that a study could be done on fruit flies. Yeah. I mean, if you can imagine how large a fruit fly is and the micronutrients that they're injecting in order to prove this.
They eat a semi-solid in a test tube. They put the media, which is like a soft gel type of food, wow. And they mix it, and they don't inject or anything. They let them eat as much as they want.
Wow!
Their diet is prepared with micronutrient or without micronutrient, and so they go and eat slowly, just like fly eats, And I mean that's one of my most surprising and mostly unexpected and most exciting for me from basic science point of view, this observation. And as you know, that most of the genetic study that we relied in the past has been on the fruit fly genetics because it is very simple. And so this has been, for a geneticist, this has been the favorite model is the fruit fly.
Wow. And then we've got it here substantiating the efficacy of your formulation. So one of the next slide that I'm going to share with everybody is one that just kind of really blew my mind there. And maybe you could describe this rabbit radiation model.
I mean, I would not have planned that way experiment, but they carried out experiment without my feedback. Only thing we did was provided them the formula. And so what they did, they give such a massive dose of radiation, which is called a central nervous syndrome dose. In other words, if you give to human, that kind of dose would be like a 5 GY, and a 100% will die within 24 hours. because of the damage to the brain. That's why it is called central nervous system syndrome. And here, rabbit, I'm talking about in rabbit, they gave a 9GY. 9GY is very, very big dose. And poor rabbit, the one which died, which had a placebo, you can see the picture, they all died within 4 hours. All died within 4 hours because the dose was so massive. But the scientists there, out of curiosity, thought, let me open the abdomen and see various organs. And you can see that he was surprised to find out that the liver in placebo group is dark and shriveled up and has no vascular system. And the protected group, where they receive antioxidant, even with that massive dose, you can see that liver was kind of protected, lobular structure is there, and there's a lot of inflammation is there, but at least it is protected.
Yeah, absolutely. I mean, you're looking at that.
I would not, with that kind of dose, I would not have accepted any protection.
Wow.
But you can see the dose was, it is almost like a liver is cooked.
Yeah.
That kind of dose.
And it's interesting. It does look like a liver color, but that's actually the lung. That's how much it had shriveled up. You were saying it's about 1/3 the size of the lung that was protected. And how much of the antioxidant, the micronutrient antioxidant formula, do you know, did they give it 7 days prior to? Or?
The schedule was the same. They gave it 7 days before, but could not do anything after because there was no time. He died in 4 hours, so it was only before exposure. In radiation experiment, Jeff, most of the study has been done giving a before radiation. But what we have found, what other people have found in laboratory, that free radicals are formed not only during time of radiation exposure, but also some of the free radicals are long-lived, lived for a few days. So you have to treat them also after radiation. So even in the mice data, that we just gave it before radiation. But only place we gave both before and after radiation was a fruit fly. Therefore, my recommendation has been always that when you give before radiation, whether you do in any place, and as well as after radiation.
Wow.
Because the existence of long-lived free radicals. Generally, free radicals is very short-lived, 10 to the minus 10 second. Is almost instantly gone, and they cause damage, and then that's it. And so I think because of the existence of long lived, it is very important to treat when you do the experiment with animal. You also give after radiation.
Well, we'll see that as we go on here with the slides. Just chronologically, here are some additional papers that you are author of. This is the British Institute of Radiology in 2004. You're talking about ionizing radiation has proven to be double-edged swords. Mm-hmm. And anyway, just amazing information. I'm going to have to skip forward here and go to another one, the British Institute of Radiology in 2005. This is talking about the humans. If you want to mention just a little bit about that, and then we've got a patent that we get to share with everybody tonight. Go ahead, Dr. Prasad.
Again, I have proposed the idea that instead of single antioxidant that people have used in the past, we have suggested that if you give a multiple antioxidant and in human against low doses of radiation, for example, when you are going to go to X-rays or CT scan or any kind of the diagnostic procedure which involves radiation, then one should use a multiple antioxidant. This was the basis and rationale there, and I have emphasized that that it is very important, not only the against low doses of ionizing radiation, which involve both X-ray, gamma ray, as well as proton radiation. So here I have emphasized why we should use multiple antioxidant rather than single antioxidant for radiation protection in human.
Absolutely, which is amazing. So going on, you've got another book here, BioShield. You mentioned just briefly, this is now moving ahead to 2008. You can understand what was going on in the country at that point, and you've got another book.
Yeah, at that time we were concerned, all of us were concerned, is that the terrorists might explode a dirty bomb, and sometimes dirty bomb people get confused. It is a nuclear bomb. No, there is distinction between a dirty bomb and a nuclear bomb is that the dirty bomb requires just any kind of radioactive materials that they can buy any place from a company. And these radioactive material emits a lot of gamma rays, beta rays, and mostly are concerned with the gamma rays. So they can deliver in a small things and throughout in any explosive devices, and they put certain amount of radioactive materials, and then it is a terrorist of, until you are very right there, you will not get too much radiation. But it is a terrorist organization, kind of a scary things psychologically rather than actual damage. But nuclear bomb is more thing. Nuclear bomb requires not only uranium 237, but we also have to devise something that can break the uranium molecules so that there is a fission or breaking of the molecule to generate a lot of energy. So terrorists can get hold of that kind of weapon and they can come and explode it. It is only possible if two major power fight with nuclear war. But most likely is the dirty bomb, which has mostly radioactive material that can pose danger only if you are close to that explosion sites. And nevertheless, even a small dose of radiation, because some of the half-life of those radioisotopes can be several years, and the soil can get contaminated, water can get contaminated. So there's a lot of hazard involved. But and again, that emits mostly concern would be a low dose of radiation rather than high dose of radiation.
Well, it's just amazing that that you have this kind of knowledge. You've put together, books helping everybody, and here's another a paper that was actually written by another individual, but he used all of your research to verify and validate this. So I'm going to just push on here. Because even in this paper that he wrote, you show the difference, or he shows the difference between the placebo and then the multiple antioxidants, and the differences there. But this is what I've been hoping to get to most of this conversation is this patent that was originally applied for back in 2002. But granted and actually issued by the U.S. Patent Office on November 11th of 2008. And I'll just read it. This is a use of multiple antioxidant micronutrients as systemic biological radioprotective agents against potential ionizing radiation risks. And what have we been talking about tonight? Exactly this. And we've got the proof. People are looking at a copy of the U.S. patent here, and so if you want to just give us a little explanation about this, and then we'll go on and just share with us.
Again, and that because of that led to the development of various formulations that I talked to you, and this for animal model one type of formulations, human we develop another type of formulations, but the idea is that the use of multiple antioxidant, whether it is in any kind of formulations or as a separate item, is a powerful radioprotective agent when given before radiation and after radiation as well. And so the patent was issued because they were convinced, because the kind of data we submitted, that this has a potential. And after that, we demonstrated, indeed, it is not only potential, it has powerful radioprotective agent.
Well, and we've just substantiated that for everybody this evening with all of these studies. The animal studies, the Department of Defense's involvement with that original CRADA and NASA participation. It's amazing to see what we have because of you, because of your life's work. Before we go, I'm gonna. We've got a couple other things here left. Let me share the screen again, and we'll talk about one of the most recent books that you've written on radiation, and it is this one. With an estimated 3.3 billion ionizing radiation imaging examinations performed worldwide each year, the growing use of X-ray based diagnostic procedures raises concerns.
Yeah.
And Dr. Prasad, just talk a little bit about this, and then we'll go on and bring that forward into what we really have available for people tonight. Go ahead.
Yeah, I mean, this is important that there is so many diagnostic procedures, which is very important. We have to have it. Like it mentioned, billions of throughout the world. And the question is, right now, the radiologists will tell you that, oh, don't worry about it. It has no risk. No, there is a risk. The more you do it, is an accumulative effect. In your lifetime, you just don't go one time dental X-ray or one time X-ray. You go multiple times, and the damage is accumulative, and increase the risk that people have estimated is real in terms of a cancer with that kind of low dose. And so the question is how one can protect against low dose of radiations. And that book emphasizes not only a low dose of radiation, but right now we have if you get exposed to very high dose of radiation, there are some procedures by which you can save individual, but they require bone marrow transplant, blood transfusion, antibiotics. These are standard therapy and very good therapy. But if you combine the standard therapy with the multiple micronutrient or antioxidant, you can save more individual from dying than you will save just by standard therapy alone. That is what I have emphasized in this book, and has proposed the idea of what kind of antioxidant you need it. And so, but more importantly, because there is very unlikely that a large number of people will be exposed to high dose of radiation. At one time it was possible, but not at this time. At this time, we are most concerned about the diagnostic radiation and CT scan or any kind of other diagnostic X-ray. And so every time you have X-ray, you have to make sure, in my opinion, I do it myself, take antioxidant preparation before going to X-ray. And I suggest my family that whatever risk is there, it will be reduced. And that was demonstrated in European study that was published in Radiology, that even one CT scan, which has a very few millisievert, less than 10, and that can induce a double break in DNA damage as measured in the lymphocytes after one CT scan. And in some other CT procedure, whole body CT scan, you can get more radiation. Point is, and then when this multiple antioxidant formulation, we used to call BioShield, gave patient before that over 50% reduction in the damage produced, DNA damage, double-stranded break DNA damage. So here is an example that even that tiny dose that people say, oh, don't worry about it, can induce DNA damage. And if you take the antioxidant before, can reduce it. What else you want to, So after that, I always thought this is the truth, but I never knew that that kind of a small dose can produce the damage first. And second, that antioxidant can protect against that damage. This, I never thought, I thought it is possible, but when you demonstrate in human situation exactly, then it becomes very powerful.
Well, really what you've described here to us this evening, Dr. Prasad, is that even those that were going to receive just a normal CAT scan, that there was a study done on just that CAT scan radiation, and you've been able to demonstrate
Yes. You will be able to demonstrate the damage, and you were able to demonstrate protection from damage by using an antioxidant before going through the CAT scan.
Wow. Wow.
That's very, very people don't pay attention to. But I said for my family, it is very important to make sure that they take a multiple antioxidant before going.
Just a couple of more concepts here as we move on. I'm going to share the screen here again. Basically, this is a true statement then. Multiple antioxidant micronutrients help with all forms of radiation damage. We opened up this evening talking about ionizing and non-ionizing, and people can look there on their screen and they can see that full spectrum. And there more and more and more, just with the cumulative effects of this radiation, we're seeing individuals that it's just like they've been swimming in this soup for so long that all of a sudden they can't take it anymore. And whether it's their cell phones, the Wi-Fi's, the cordless phones, 5G is coming out. All of these things are going to be just more prevalent because of things like this. People are actually feeling the effects from this type of radiation. And could you take just a moment and just
most of the study, or almost all studies, has been done what we call epidemiology study. In other words, people were recruited who are exposed to longer period of time and did the study. But it was not the study like a double-blind placebo type of a study. So it was a prospective study, epidemiology study, where evaluated the people who are living in an area where there is a high exposure of electromagnetic radiation, either from the cell phone and they found that there is some risk. For example, if you have a cell phone and using 10 hours a day and close to your ear, it can increase the risk of certain kind of brain cancer. Again, this is epidemiology study, and many people question the validity of this kind of a study because they say this is an association rather than cause and effect.
Exactly, and we really can't go down that path tonight. We don't want to make any medical claims, but there, even in the book that you just referenced, that Radiation Injury Prevention and Mitigation in Humans, published in 2012, you've got an entire chapter there on non-ionizing radiation and
how one can reduce of non-ionizing radiation. Yes, right.
So that is awesome. I want to take a moment here and introduce MicroDaily. This is what I've been taking. I've been drinking, and if you want to, I'm going to go ahead and hit stop share so that we can see you. But take just a moment and talk a little bit about MicroDaily and the formula there that is in hydro. Go ahead.
I think both MicroDaily, either in a capsule form or hydro form, have exactly same formulation. And I will just give you briefly that why it is unique formulation. First, it is well tested in both human and in the animal model. And second is that, for example, it has two forms of vitamin E acetate and vitamin E succinate. Vitamin E succinate I discovered, like you mentioned, in early 1980s. It is the most soluble form of vitamin E. It can cross blood-brain barrier easily than vitamin E acetate can. And vitamin E succinate is also produce some unique effect that cannot be produced by vitamin E or any forms of vitamin E acetate. So this is unique combination. We also have a separately vitamin A and beta carotene as a separate ingredient. Most of the time in the industry thinks that beta carotene and vitamin A are same. but they are not same. They each produce some unique function. They share some common function, but they also produce some unique function that cannot be shared by others. Also, that we have a both antioxidant that we take from the diet and antioxidant that our body makes it. So this is very important to remember it. And we also that, as you know, we have not included in any iron, copper, or manganese in this formulation of Micro Daily, because these minerals combine with vitamin C and generate free radicals. And once they enter into the body, there is no way they can get rid of these trace minerals. So their body becomes saturated, and any slight increase in the level of your body store of iron, copper, manganese can increase the risk of many human chronic diseases. And a small amount, tiny amount, that's what is called trace mineral. Tiny amount is absolutely essential for your health. You must have an iron, copper, manganese, but excess will create havoc as well. So we don't add those kind of things. We also don't have any heavy metal because they are very neurotoxic. We don't add also any herbal product because we don't know their purity, and many herbal product interacts with the prescription and non-prescription drug and in adverse manner. So we have not added that. And every ingredient which are there is an active one. It is absorbed. It can cross blood-brain barrier as well, because many animal studies shows with the individual macronutrient that they get affected, whether it is a model of Alzheimer or any model they have studied in human. And the macronutrient, individual macronutrient, can affect and can improve their symptoms. And limited a study with what had been performed with the individual macronutrient, they showed that it can cross blood-brain barrier. So everything we have there, at least from the animal data, suggests that all ingredients they're safe, they're active, they're absorbed, they can cross blood-brain barrier.
Wow, wow, Dr. Prasad, just what a wealth of information. It's hard to believe that we're almost 45 minutes into this presentation, and we have just been so well just educated through your life's work. I mean, we reference a book that in 1974. I mean, there's people that are probably watching this that weren't even born at that point. You know, and then we've moved it all the way forward to where now in 2018 we are talking about the things that are affecting all of us. And so thank you for spending the time here with us this evening, talking about radiation, talking about your life's work, letting us reference so many of the things that you have contributed, not only to humanity. Dr. Prasad, we thank you for what you've brought to Engage Global, and just the individual that you are, your humbleness, and being able to spend some time here with us this evening. Is there anything else that you would like to add before we close this evening's presentation up?
Well, I want that this for improving health of the individuals, families. I want that everybody should have this so that they can enjoy healthy aging, as well as, get less cold, less fever, any kind of infection. But the question is, for me, these products that I have developed is for your optimal health and healthy aging, so that you don't get sick or ill health. And if you can reach as many people, and you have done very good job, Jeff, and I want that everybody should have this product for himself or herself and the family.
Wow. Well, I am so honored, Dr. Prasad, to have hosted this evening's science presentation. And I hope that those that are watching it will get back with the individual that shared this presentation with you. Know that we do have the science. It's not science fiction. This is the science. We've demonstrated that, and we have an incredible, humble individual that has shared his evening here with us tonight, Dr. Kedar Prasad.
Thank you, Jeff.
Thank you so much for being on this evening. I will just say goodnight, and let me see. We'll quickly share as we leave so that we can. There we go. We can say thank you. Thank you, Dr. Prasad, for all that you have done. We do appreciate and are humbled that you'd be here with us this evening.
Thank you, Jeff. Thank you.
Bye-bye.
Bye-bye.